Welcome to this masterclass explainer. Think of this as your professional AI training bootcamp. Today, we aren't just talking about abstract, floating concepts. We're actually building your technical muscle memory. We're going to break down the architect's handbook, covering the 20 absolute core pillars of artificial intelligence. Listen, whether you're building these systems from the ground up or just directing them, you've got to know the anatomy of your tools. So grab your gear and get ready to sweat a little, because we're going to move fast, train hard, and architect some serious knowledge.
Okay, let's dive right into this. Here is our training schedule for today. We'll be hitting 5 targeted modules. First, foundation and core AI mechanics. Second, understanding large language models. Third, customizing your AI model. Fourth, prompting and AI agents. And finally, control, creativity, and efficiency.
All right, Module 1, Foundation, Core AI Mechanics. Let's get into it.
Consider this our warm-up phase. Before we can start lifting the heavy weights of generative AI, we've got to understand the underlying anatomy that powers literally everything else. Our very first pillar is the neural network. This is the fundamental muscle fiber of AI. Data comes in through the input layer, and then it hits the hidden layers. Now this right here, this is where the actual learning happens. Just like building physical strength through endless repetition in the gym, the network constantly adjusts its weights as it processes data over and over again. Finally, it pushes out a result in the output layer. This continuous adjustment of weights is absolutely crucial. It's exactly how machines learn from real-world examples.
Okay, let's move to transformers and see how this builds up our foundation. So older sequence models, they had to process data one piece at a time. It was kind of like reading a book strictly word by word. Painfully slow, right? Well, transformers changed the entire AI landscape. They use encoders and decoders to enable parallel processing. This means that AI can look at a whole sentence or even a whole document all at once. This massive, massive upgrade in efficiency is literally what made modern AI possible today. But here's a question for you. In a massive sea of data, how does the transformer know what actually matters? That brings us to pillar number 3, the attention mechanism. It allows the AI to weigh the importance of different words in a sentence relative to one another, so it actually understands context. For example, it figures out that the word bank means a financial institution and not a river edge, entirely based on the surrounding words. It's essentially teaching the AI how to focus under pressure. Module 2, Understanding Large Language Models. These are the engines of modern AI. All right, we're warmed up, so it's time for the heavy lifts. Let's look at the core engines driving today's most powerful text-based technologies. Pillars 4, 5, and 6 basically operate together as a single workflow: large language models, tokenization, and embeddings. An LLM's entire training process is, at its core, based on token prediction. It's just guessing the next piece of a word in a sequence. But to pull that off, it first has to fundamentally change how it reads human language in the first place. Now, what's really interesting about this is how these 3 pieces connect. We always start with text, human language. Then, the AI breaks this down into tokens, which are just data fragments. Think of tokens as the syllables of AI. But tokens alone? They don't really have meaning. And that's where embeddings come in. The AI converts those tokens into numerical vectors. It literally maps the semantic meaning of a word into a set of numbers, which allows the machine to mathematically calculate the similarity between different concepts. This right here is how a machine actually understands meaning. It's brilliant. Moving on to Module 3, Customizing Your AI Model. Time for some domain-specific drills. So now that we know how the machine processes language, how do we train it to do exactly what we want? This is where we run those domain-specific drills. Pillar 12 in the handbook is the vector database. Remember those embeddings we just talked about? The numerical representations of meaning? Well, they have to live somewhere, right? Vector databases are storage systems built explicitly for this. Because the data is stored as mathematical coordinates, it enables incredibly rapid similarity searches. And honestly, this is the backbone of almost all enterprise AI search applications today. Now, when you're customizing, you're going to face a classic training crossroads: RAG versus fine-tuning. Retrieval-Augmented Generation, or RAG, is basically like giving your AI an open-book test. It connects the AI to external knowledge, like a vector database, via a retrieval pipeline. This lets it reference your specific company data on the fly. Fine-tuning, on the other hand, that's like sending the AI back to school. You're actually altering the pre-trained model so it deeply understands a specific domain or tone. Both have their trade-offs, and trust me, brilliant architects know exactly when to use which. Speaking of fine-tuning, Pillar 19 is transfer learning. This is your ultimate training shortcut. Instead of training a model from absolute scratch, which, by the way, takes a massive amount of computing power and time, transfer learning just reuses previously learned knowledge. It's exactly like a professional athlete taking their existing balance and strength and applying it to a brand new sport. You don't lose the foundational muscle, you just adapt it. Module 4, Prompting and AI Agents. This is the execution phase. Okay, we've built the foundation and we've customized the model. Now we enter the execution phase. This is all about your form, how you, the human, actually interact with the machine to get the absolute best performance. Let's talk prompt engineering. We have two primary approaches here, zero shot and few shot. Zero shot is asking the AI to perform a task blind, with absolutely no prior examples. Few shot is when you provide a couple of structured examples right there in your prompt to guide the AI's output format. So the crucial point is this. Your AI is only as good as the instructions you give it. Providing just a few examples will drastically improve your accuracy. Pillar 10 is a specific, super powerful prompting technique called chain of thought. Sometimes, if you ask an AI a really complex math or logic problem, it fails completely if it tries to just jump straight to the answer. Chain of thought forces the AI to output its step-by-step reasoning before giving you that final answer. By slowing the AI down and making it literally show its work, you overcome its limitations and get vastly better results on tricky problems. Now, when you combine great models with great prompting, you get AI agents. That's Pillar 11. Unlike a standard chatbot that just talks to you, an agent handles complex, multi-step workflows autonomously. First, there's planning, where it breaks a big goal into smaller tasks. Second, tool usage, where it might actually go browse the web or run Python code to achieve those tasks. And third, memory, where it keeps track of everything it's learned across the whole interaction. Finally, Module 5, Control, Creativity, and Efficiency. Time to apply the guardrails. We've reached the final cooldown module. This is where we apply the guardrails, tune the performance, and align the AI to operate safely and efficiently. Pillar 14 is temperature. Think of this as a literal dial you can turn to control the AI's creativity. A low temperature means the model's going to be highly focused, predictable, and exact, which is perfect for writing code or analyzing a legal document. But turn it up to a high temperature, and the output becomes creative, diverse, and kind of unpredictable, ideal for brainstorming sessions or creative writing. Next up, we absolutely must manage the context window and mitigate hallucinations. The context window is basically the token limit. It's how much of a conversation the AI can remember at any one time. If you exceed this limit, the AI just forgets your earlier instructions. And when an AI lacks context or training data, it might suffer from hallucinations. That's when it confidently, and I mean confidently, invents false information. Managing your conversation length and using grounding techniques like RAG are exactly how you prevent this from happening. Pillar 18 requires a really quick cross-training pivot over to visual AI, diffusion models. While LLMs are busy predicting tokens, models like Stable Diffusion are generating images. And they do this through a genuinely fascinating process of noise removal. They start with a screen of static or just random noise and iteratively refine it step by step until a completely clear image emerges based on your prompt. It's like sculpting a masterpiece out of pure static. Finally, let's look at advanced optimization, RLHF, LoRA, and quantization. These are your go-to techniques for compressing and aligning models. RLHF uses reward models based on real human feedback to ensure the AI behaves safely and actually aligns with human values. LoRA provides parameter-efficient fine-tuning. It uses lightweight adapters instead of changing the entire massive model. And quantization, that literally compresses the model, drastically speeding up inference times so you can actually run these incredibly powerful tools on standard everyday consumer hardware. And there it is. We've officially completed the bootcamp. You now know the mechanics, the language, the training, the execution, and the optimization. You've got the 20 core pillars from the Architect's Handbook securely under your belt. But remember, knowledge is only potential energy until you actually apply it. So I'll leave you with this final, crucial question. How will you architect your own AI workflow? Take these tools, get out there, and start building something amazing. Until next time, keep training and keep learning.